Yay, we made it to lesson 2-10, the last one for lesson 2. They give you 1, 2, 3, 4, 5 vocabulary words in this lesson, but honestly, I couldn't bring myself to make you write them down. What I do want you to know is this formula. This is the percent change formula. Percent change is equal to the amount of increase or decrease over the original amount, and we're going to practice with this a little bit so it will start to make more sense. I'd like you to find problem 1 on page 145, please. As they say here, one common reason why you might need to find a percent decrease is because you're trying to find a percent discount, trying to figure out how much money you're going to save. So I'm going to quickly walk you through this. You can stop the video and go through this more slowly if you like. Coats on sale. Original price is $82, sale price is $74.50. What percentage was the change? Well, here's your formula. Percent change is equal to the amount of increase or decrease over the original amount. So we are going to find out how much the cost went down. So we're going to take the original price of $82, subtract the new amount of $74.50, and divide it by the original amount. Note that 82 is in this fraction twice. Plug in the numbers you know, 82 minus 74.50 over 82. Simplify the numerator, divide, and there we go. And you end up with an answer of 0.09, but you're not done. Convert it to a percentage, which is 9%. Take a look at got it number 1. The average monthly precipitation, blah, 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 4.1 inches in December, 2.8. What is the percent decrease? Now, I want you to give this a try on your own in your notebook. Stop the video, I'll wait, then we'll go over it together. So we are looking at how much the amount of rainfall went down. So our percentage change for this one is going to be the amount of decrease over the original amount. And the numbers they give us, 4.1 inches to begin with, changed to 2.8 inches. So we're going to subtract 2.8 from 4.1. And remember, the original number is in this formula twice, so it's up here in the numerator. It's also down in the denominator. We end up with 1.3 over 4.1. Divide that, you get, it's a little hard to read, 0.317. I'm going to round. That's approximately equal to 0.32. Don't forget to change it into a percentage, so it becomes approximately 32% change in rainfall. So problem 2, as you might guess, involves finding a percent increase instead of a decrease. Store buys a guitar for just under $300, then marks up the price to $340. What is the markup shown as a percent change? Well, we're going to show the amount of increase over the original amount. This time we're going to start with 340 minus 295. Original amount is still in there twice, 295. You can see they've substituted in the numbers they know. Simplify, 45 over 295, divide. You end up with approximately 0.15, which is 15%. There is a 15% markup on that guitar. Same thing, try got it number 2 on your own. And once you've figured it out, you can check your answers with mine. All right, the tolls are going up. That always makes everybody happy. Our percent change is going to be the amount of increase over the original amount. Well, the new toll is $3.50. The old toll was $3. Remember, the original is in this formula twice. So 50 cents over 3. Divide, you get 0.166. Round, you get approximately 0.17. Turn it into a percentage. Tolls are going up 17%. That's kind of a lot of money. So on page 146, they introduce you to something that they have listed as completely new, relative error. I'm not going to call it something completely new. I'm going to say this is really like percent change. It's just a variation. So up here, watch out, and I'm going to scooch my notebook. Up here we had percent change is amount of increase or decrease divided by the original amount, or putting in a variation. The relative error is going to be the amount of error divided by the actual value. And let's work through a couple problems, and then these words will start to make a little more sense. I want you to have this formula written in your notebook, just like that, please. So of course they stuck in another multiple choice question right when I really am trying to get you guys just to understand what they're talking about. Anyway, here's an example where you might see this thing in action. A decorator estimates that a rectangular rug is 5 feet by 8 feet, but the rug is actually 4 feet by 8 feet. So the question is, what is the percent error in the estimated area? So percent error is going to be the difference between what she said and what it actually is over what it actually is. It's very similar to what we were just doing. She said it was 5 by 8. It's actually 4 by 8. So 4 by 8 is in here twice. 40 minus 32, which is equal to 8, divided by 32. She was off by 25%. Got it, number 3. Take a look, see if you can manage it on your own, and then check back with me. So let's say that Amy has asked you to keep track of the walking you do every day, for example, and you have estimated the distance that you walk to your friend's house. Let's figure out how accurate you are. Here's our formula. Percent error is going to equal the amount of error over the actual value. You said that it's 5.5 miles to your friend's house. That's a pretty good walk, by the way. It's actually only 4.75 miles to your friend's house. And we have the actual value in the denominator, just like we were doing with the first couple kinds of problems. So simplify the numerator, you end up with 0.75 over 4.75. Divide gives you 0.157. which is approximately 0.16, which is 16%. So you are off by 16% in how much you've been walking, or maybe biking. That's kind of a long walk. Before we move on to problem 4, I want to show you a little shorthand that I really like for these percent change problems. And it's even a seasonal shorthand. When I have to do a percent change problem, I just think of the witch's hat, because this triangle is a scientific, well, the triangle in the Greek alphabet is letter delta, and delta is a scientific symbol meaning change. So change over original, which is what we were using for all those problems. How much did the amount change? Divided by the original amount. And you can also think about it as looking a little bit like a witch. Not that that drawing of a witch is particularly good, but delta over original, the witch's hat, will help you with your percent change problems. Just remember, how much did it change? Divided by the original. You're all set. I'm a little skeptical of this finding minimum and maximum dimensions thing. I'm not sure why they stuck it in at the tail end of this chapter when we've been doing so many other things, but you've got a poster and you want to frame it. You measure the length of the poster, 18.5 inches, to the nearest half inch. Well, if you are measuring to the nearest half inch, how much could you possibly be off? Well, you could be off by as much as 1/4 of an inch, and let me show you why. If I'm using a ruler that looks like this, that only has the inches and the half inches marked, when I go to measure the length of something, I have to guess anywhere between the inch and the half inch. I need to guess, is it closer to the half inch mark? Is it closer to the 1 inch mark? So you could be off by, well, about half that much, right? Come on back to your book. So they're saying take the measured value minus the possible error. So you measured it as 18.5 inches, but you might be off by as much as 1/4 of an inch. So the poster could be as small as 18.25 inches. But if you were off the other direction by half an inch, we'd have to add that. So the poster could be as big as 18.75 inches. Somewhere in between 18.25 and 18.75 is the actual measurement of this poster. which all you wanted to do is just hang up on your wall. What a lot of work for that. Number 4, I don't even want you to write it down, I just want you to think. A student's height is 66 inches to the nearest inch. What are the minimum and maximum possible heights? Well, if you're using a ruler that doesn't even have half inches on it, that just has inches on it, you could be off by as much as half an inch. So, we measured him or her to 66 inches, so he could be, or she, could be between what and what? Think it through. So problem 5 is a long, ugly problem to end the chapter with. I don't want you to stress about this too much. Just let's walk through it, see what you can take away from this. Here are the measurements of a box to the nearest inch. And they want you to figure out the volume of this box and the greatest possible percentage of error you could make in figuring out the volume of this box. Well, you know how to find the volume based on this, right? It's just length times width times height, so you multiply those numbers together, which they did right over here, and you end up with a volume of 360. But what if those numbers were off? We talked before about how we could be off by a half. So, well, maybe it was only 11.5 inches long, and maybe it was only 5.5 inches wide, and maybe it was only 4.5 inches high, which means the minimum volume could be 2.84.625 inches. And then if we do the same thing to find a possible maximum volume, it could be 446.875 inches. Oh, do you hear my phone ringing? Better go get that. So our maximum volume could be as big as 446.875 inches. Now, here's thing 1 that surprised me. And I had to think about it a bit. I'll let you think about it a bit too. The differences, the minimum volume was off by 75 and change inches. The maximum volume was off by almost 87 inches. I just guessed that those numbers would be the same, but they are not, and I'll let you think about why. So, we're going to use 86 because this is the bigger number that we came up with. The bigger difference in volume over the measured volume gives us 24%. The volume of this package that we started with could be off by as much as a quarter, which I thought was really surprising. Last but not least, turn the page to 148. This is a reading carefully alert. They're calling this a reasoning question, which you may have noticed by now doesn't always mean do the math. If the box's dimensions were measured to the nearest half inch, how would that affect the greatest possible error? Would the greatest possible error be the same? Would it be bigger? Would it be smaller? You think it through. I'm going to grab my notebook and show you something. So I actually went through and figured this out, but before I start, you should have fixed in your mind what happens with the percent error. Does it stay the same? Does it get bigger? Does it get smaller if we measure to the nearest half inch? Well, measured volume is not going to change, 360. Minimum volume, I'm using different numbers because our possibilities are different. We end up with 320.921 as a minimum volume. Maximum volume, 401.953. And then I take those two and I end up with, again, different numbers here. I'm going to take the bigger one, 41.953 over the measured volume, which is 0.116, or about 11%. So that cuts your percentage error in more than half. That's pretty good. Remember, I offered you a different option for the problems that come next. You can do them as homework, or you can bring them in tomorrow and do them as classwork. I want you to work on number 7 through 23 odd. And that is the end of this chapter.